Hello and welcome to Bicep Real episode 10. This week we're going to start taking a look at a topic I'm going to call governance. And this is going to wrap up a few different things. So a lot of this is going to be about testing, but we're also looking at some other features that we're going to implement just around security controls or promotion controls and those sort of things that are going to help us add more control around how our code and our infrastructure makes it between environments or makes it from development into production. And so it's more than just testing. We're going to wrap it with a label of governance, and you'll see more when we dive into things. As always, we're working on our Land the Toys project. We've got our environment all up and running with all these resources. And if you remember from last week, we actually have our Azure DevOps pipeline, which is now running deployments that go through from development environment to test environment to production with different values for configuration and so on. And we've got all that working. So we're going to have a look now at adding some more controls. And we're going to do a few different things.
Okay, so the first thing we're going to do is look at implementing branch controls. For this, you need to have a bit of an understanding of how Git branching works and why we want to use that. So we'll quickly run through that. So up till now, we've been using our Git repo to store our code with a single branch. So effectively no branches. And the branch is called main. Now this diagram here is called master. There's been a name change on those, but now it's called main, but the same principle here. And what we can do with Git repos is we can create branches. So they allow you to take the instance of the code at a particular point, copy it into a branch that you can then work on independently of the main branch, so that you can make some changes. You can have a local copy that you adjust, but you can still commit that code back to the Git repo. You can still have all the version control and storage for that, but all of that work is stored on a branch, which is separate to that main branch. And that allows us to keep a main branch that is working and is ready to use, and anyone can do a deployment, whilst doing all of our development work on a separate branch that is off to the side. We can make our changes in there without affecting anyone being able to do an actual production deployment if they need to, because that code is coming off the main branch. Once we're ready to, we finish the development work and we want to actually get that into our main branch and have that be used by a normal deployment, then we can merge that branch back into main, and that work will then become part of that main branch. You can see that here. You've got, we've taken off a branch here onto the all work section, this blue one, and we've done a few commits on it. Those circles are commits. So we are still having version control. We are still storing our work on the remote Git repo, so it's backed up and so on. And then at some point we've decided, okay, we want to now merge this in, and we merge that into the main branch. But at the same time, somebody else can go and do the same sort of thing and create their own branch. That branch has no relationship to my branch, so anything they do is completely separate to what I'm doing. And so it makes it much easier for working with teams as well. Now, a very common convention is that you don't want people working on the master branch or the main branch. You don't want them sort of, doing day-to-day development, doing a check-in at the end of the day to commit their code into that, and it getting added to the main branch. It's a very easy way of somebody breaking main before you go home. So what we want to do is basically make sure that people do their work on a branch and then follow a process to merge that branch back into the main branch. And so we can do this with branching policies. Basically, what we're going to say is firstly that you can't commit directly to the main branch, and that you need to use what's called a pull request process. And the pull requests effectively are a way of saying, okay, my work is ready on my branch. I would like to merge it into the main branch. And here's some documentation about what I've done. And it creates what's called a pull request, which we'll see in a minute when we do that, which is available in the UI. And generally we want people to come and have a look at it on your team and then have a review of the work. So it's not just you blindly pushing your code into main. It does have some overview from somebody else, and they can then approve the pull request, and that will allow you to merge that into the main branch. So we want to set up some policies to do that. So if you remember, our Git repo is in GitHub, even though we're using Azure DevOps for our actual pipelines and so on. If you're using Azure DevOps repos, you can do the same sort of thing as well, or any other repo tool will have the same sort of thing. So what we're going to do, we go into settings and we look at branches, and we've just got the one branch at the moment. And what we want to add is some branch protection rules. So first up, we want to require a pull request before merging. You can't just merge straight into the main branch. We also want to require approvals of pull requests, so that somebody else has to review the pull request before they can actually merge it. And then you can set the required number of approvals here to any number of people. We'll leave that to 1. And then we also need to add in here and to say what branches we want to protect. So we're going to protect the main branch. I think that should do it. We can do some other things as well. So actually, one of the things that's here, because we're going to do this in a minute, is require status checks to pass before merging. So this basically allows us to force any tests that we need to run as part of a pull request to run. We're going to break one of those in a minute, so I'll leave that on. It'll make more sense once we've got that in there. We can do a few other things in here. So we can say require conversations to result resolution before merging. That's quite a good one to have. So most tools, GitHub, Azure DevOps, allow you to have a conversation and pull requests or something, add comments, say, you should really fix this or you need to change that. And so, and you usually there is a option to resolve those comments. So yes, I fixed what you asked me to do, and you can require that to be done. So somebody has to, if there's any open conversations, they won't be allowed to merge, and you can, and you can add a few other things in here as well, but we'll stick with that. So we'll add that policy, and that's now good to go. So we set up our policies. And one of the things we want to do now is we want to run some tests. So we're going to run some validation tests that check our code for certain things before we're allowed to actually merge it into the main branch. This is kind of a checkpoint. So you finish your development, you come in, you run a PR, we create a PR to merge it into the main branch. And we're going to trigger some tests at that point, do some automated testing and say, okay, thank you for your submission. Let's check it against some of our guidelines or requirements and make sure that those test pass before you're allowed to merge it and get your code into the main branch, which can then be deployed. This is a good protection because it stops any of that code getting into the main branch. That we remember that main branch is what we're using for our normal day-to-day deployments. We're going to deploy to our dev, test, prod environments. We're going to use that main branch. Now, you may have other environments that you're using to actually test that branch, or maybe even we do a test deploy of that branch into the development environment because that's allowed. But we would never deploy a development branch into the production environment. That would just be bad. So we want to make sure that this code is checked before it gets into that code. So what we're going to do, first up, we'll create a new file and we're going to call it, this is what we're going to use. Now, at the minute, we're on the main branch. You can see down here, it's got main. Okay, and so what I'm going to try and do is do a commit to this to show you how those policies work. If I do this, it'll allow me to commit it here. So you saw it, well, that worked because this is my local copy of the Git repo. That's fine. But if I try and do a push, I should now get an error, he says. Okay, so a quick check means I missed something on the branch protection rule. So if we go back into the branch protection rule, by default, if you're an admin on the repo, the rules don't actually apply to you, which is, I'm not sure the best approach. But if you come down in here, there is an include administrators option here. If you tick that, that makes sure those rules also apply to administrators. We go back to code and I try and push that change again. You get an error. Now, you get the error in VS Code isn't actually all that helpful. It says it can't push the remote try pull to integrate changes. So it looks like you actually need just to do a pull to update. If you try and pull, it will work. It will do the pull, but it still won't allow you to push. So if you open the Git log, you can actually get a bit more information. And you can see here, it gives you an error about protected branch requires improvers. Now we know we can't push the main anymore. What we need to do is put those changes on a branch. Now, a very common thing I do all the time is forget about this, make a lot of changes locally, commit them, and then get that error and realize, oh yeah, I can't push the main. That's not a big problem because what you can now do is create a branch off of main right now with all the changes you made, and they will move into that branch. So what we'll do here is Control-Shift-P in Azure DevOps and go to create branch, and we'll give it a name. You just need to give it any sort of descriptive name. So we'll call it, this is us adding a PR test and PR testing. And you can see now this is changes to PR testing and this changes to publish branch. So the minute the branch just exists locally on our machine, it doesn't exist on the server. So if we hit publish, that will push the branch and any changes that we already had in there up to Azure DevOps, sorry, to GitHub even. If we have a quick look over that code, and you can see now it's telling me it's accepted I had that branch. If you look at the branch list, we've got this PR testing branch. It's asking me if I want to do a pull request or that. We won't yet, we'll come back to that. But first, let's go ahead. Okay, so we've got a blank YAML file here. We're going to add a few, this is an Azure DevOps pipeline, so we're going to add a few options for this. The first thing is we are going to have a trigger set to none. Now, this is a trigger based on a standard sort of, we don't want that. What we want is a PR trigger. So we're going to add PR here. That's going to ensure it's triggered on that. And then we are also going to add a path value in here. What this allows us to do is say we only want this triggered when the change includes changes to particular path. And so we're probably interested in adding the configuration. This basically means if somebody makes a change to something else, like the README or maybe a pipeline change, it's not going to trigger these particular tests because these are only relevant to our actual. And so now we're ready to set up our tests. Well, we're only going to do one test at this point. What we're actually going to run here is we're going to use the ARM TTK. We have the ARM TTK, or template toolkit, is a set of basically best practice tests that we can use against our code that will check that we're not doing stupid things within our template. So it looks for things like hard-coded things where they shouldn't be. It looks for using old versions of API versions, out of date things, all these sort of things. So we're going to look at fixing, we're going to look at running those tests as part of our pipeline. So this is the TTK. You can download it. You can run it locally on your machine. It's basically just a lot of PowerShell. So if you wanted to test fix locally, you can do that. We're going to run it as part of our pipeline. And to do that, we are going to use a Azure DevOps extension. Bit of self-promotion here because I wrote this extension, but it is a pretty useful one for basically allowing you to run the TTK without having to install any of the things. It'll take care of all that for you. So it will run those tests. So we want to use this extension. This is actually a new version of the extension. It was released a couple of months ago, hence why it's a fairly minimal amount of installs at the moment. I'm not actually really been promoting it that much, or should. So this is the cross-platform one. It will run on Windows and Linux agents. The older version, I'll quickly just bring up, is this one. You can see it's got a lot more installs. This one just ran on Windows. This one still works, so you can still use it, but the cross-platform one is the best one to use. And so we want to make sure that that's installed in our Azure DevOps instance. So if you click on Get It Free, it will take you to the option to install that within your Azure DevOps instance. I think I should already have it installed. I did my testing in that instance, so it should already be there, but maybe I had a preview version. I'm just going to select the right org and install that. And so that should be installed, and you can go and check it if you want. If you're an organization owner, you can go to the top level of your org, go to organization settings, and if you look at extensions, and then you should see you've got the extension installed. I've got a few you can see here because that's where I do my testing as well, but you should only have. We'll go back to our pipeline. We will now do is go back to VS Code, and we are ready to start using this to test our resources. So we've got our step section. We need to add a task. Key thing here is to get the right name of, so you can trust me that that's the actual task and to use. One sheet you can use to actually get the right syntax for the particular step you want to do is to go into a pipeline in Azure DevOps. Any pipeline doesn't really matter. Click Edit and ignore that. And then when you get to the editor, just scroll down and find some empty space at the end. And in the right-hand side, we're going to search for our task. So we can look at TTK, this particular one, and it will give you a sort of a wizard here to actually fill in the values. And so all we need for this one is we need to give it the path where our files are. So our files are going to be within the instructor folder. And where do we want to put the results of the test? It's going to be probably later. So we're going to add a results folder. And then the rest of it, we're going to leave as add. And you can see here, this is added the syntax for that to this file. So if we just cut that, we don't want to save this. So just exit out of that to make sure that we don't make any changes. Go back to VS Code. And we've got our syntax here that we can stick that in. And that should do what we need. Now, the way this TTK test extension works, what it does is it runs all the tests for us and it spits out a load of XML files in a particular format. In this case, NUnit. It's a well-known testing results format. Spits those out to that results folder. We want to take it a step further than that, though. And what we want to do is be able to display those test results in the Azure DevOps UI. And so there is a built-in extension that will do that. So it will take common test format results, in this case, NUnit, and integrate them into the UI. So we're going to come over here and we're going to add another task. Just going to copy and paste and walk you through it. So this is the publish test result task. You give it a name, explain it, that's not too important, but this is where the important bit is. You tell it that the format of the files is NUnit. That's what the TTK test outputs in. And then you tell it the test files are in this results folder. Switch those to, we're going to use a Windows agent, I think, for this, but you could run it on Linux. And then this path here, so all those files that are outputs, they have a -arm TTK docs, and at the end of it, that's the way the extension works. So you've got a wildcard there. Now, this bit at the end is very important to make sure you add this condition always. So by default with Azure DevOps, if a task before the task fails, then the next task won't be run. It'll be skipped because that failed. Now, the ARM TTK test result extension there is designed to fail if a test fails, to show you that you've got failing tests. But we always want to push test results, even if they fail. In fact, particularly if they fail, because they're going to be more useful to us. So this condition here basically says you always run this task, even if the preceding task failed, so that we get our test results outputted into the. The last thing we need to do is make sure we actually add a pull for this to run on. We want to use Microsoft hosted data. We're going to use the Windows ones. So we'll just add this in to make sure this run on the Windows latest image. You could run on Linux, that'd be fine. You just probably need to change your slashes in the path, but this would all work on Linux as well. Okay, so that is done. We will see if it actually works. Just going to check my spelling of everything. That seems to be okay. So we go ahead and commit that, push that up to our branch. And now we want to test that actually works. So we don't actually have to submit a PR to test this out. We can manually trigger the pipeline. So if we go back over to Azure DevOps, and first thing we're going to do is create the pipeline. So we go to new pipeline that we did before. We're going to use GitHub. Don't need any of those. Pick the toys one again, like we did last time. Going to use an existing pipeline. Now, because this pipeline doesn't exist on the main branch, we're going to have to select the PR testing branch. And you should see we've got the PR.yam. Okay, so we'll go ahead and create that. And that's looks like what we said before. So let's go ahead and run that and see what doesn't work, because this is a pipeline. And if you get it to work first time, I think you might be some sort of god. So it will, I'm sure, fail on something, but we'll see what happens.
Okay, so predictably it did fail. There were a couple of issues, but mainly one of it seems to be some sort of bug with the compiling of a single Bicep template in the extension. I'll need to have a look at that later. We've worked around it. So what we've basically done is we've added an extra task at the beginning. We've added this PowerShell task, which is going to go and the template. It gives us actually an extra level of testing because it will do some linting. The Bicep command actually has some linting to check if the Bicep code is valid and will fail if not. So that will do that. It compiles the template and then we feed that template into the actual TTK tests and so on. And so if we go back over to the pipeline now, you can see that this has failed, but this is a good failure. This is failing because some of the tests has failed. As you can see here, failures found test results. So if we go have a look at the test page, and this is where that publishing comes in. So now I've got a nice UI to see the tests that have been published, and I've got some failures here. So I can see API versions should be recent. So this is telling me I've got some API versions that are older than expected. So if we click on that result, you actually see here it tells me which API version. So API version has been latest, around 2 years old. And we've got Microsoft Network Security Groups and Virtual Networks are both old versions, so we need to look at updating those. We've also got some blanks. So these are saying that there are some blank values somewhere in the template. Now these are a little bit harder to fix, particularly because we're looking at Bicep, and this is where the ARM TTK was built for ARM templates, and we've kind of used it to test Bicep by compiling that into JSON. Now if you've got a single Bicep file, that's fine. But obviously, where we're taking multiple different Bicep files and compiling, like using them as sort of submodules, when we compile those into the JSON that actually gets tested, it's one big file. And so finding where those blanks are is not necessarily the easiest. Yeah, there's no obvious marker in it, so we're going to have a look at those and see what's going on. Whereas here, there is a variable it's complaining about that we're not using, slightly odd one, so we'll have to have a look at that and see what's going on there. So a few things we need to fix there before we can actually go forward with that. So we'll fix those in a bit, but what we're going to do now is just actually merge that change so you can see what the PR process looks like. So if we go back to our repository, and you see here there's a nice hint here. It's noticed we've already worked on this, so do you want to do a pull request? So we can click on compare and pull request. And it shows us what we're doing. You can see here, so we can add comments here. So we're going to add a comment here for anyone who wants to review. You can add some values here if you want. You can assign it. You can say, okay, this is a enhancement. You don't have to do that. It's up to you. And create the pull request. Now you can see we've got a few issues here. Firstly, it needs a review by somebody, so I can't merge it until somebody else has reviewed it. And it's already picked up that these pipelines need to run. Now we've got a little bit of a bug here I think we need to fix because it's running both the testing and the actual deployment. So we need to have a look at our deployment code as well. But we're going to need to fix those because they're going to fail. So let's quickly have a look at this and see why it's running that additional one. So if we go over to VS Code, so we've got this. Now this should only be triggered on a main branch. So why is that triggering on this branch? Okay, so what we can do here is we can add an explicit PR non option there. We should force it to not run those when we do it on a PR branch. But we're also now going to have to go and fix those issues with the TTK pins up. So I'm going to have a look at those and come back to you. Okay, so we fixed up the tests. Some of them are easy. So the ones with the API version were pretty straightforward. We just needed to update the ones for, say, the VNet to the latest one. That was easy enough. Some of the empty values were a bit more difficult. So there was a couple of Cosmos ones where the options array was empty, so we could just remove that. That was fine. But the other one was in this Swagger file we're using. There were some empty arrays in there, which are getting picked up by TTK. Not sure that the TTK should actually be picking those up. There might be a bug, but we cleaned those out. And when I run the TTK test locally, that now works. So hopefully, when we go back to our PR and we wait for this test to complete, hopefully that should come back green.
Okay, so we did in fact see some more failures. I fixed these up now, but I thought it was worth just going through them because they were a bit weird and it might be worth seeing what was going on. So the first thing we saw is we got this failure about a variable needing to be referenced as a test. I initially thought, okay, I've missed a variable. But if you go look at the actual error, you can see you've got a very weird error here with this weird variable name. And that isn't the variable I'm using. It's not one I've created, so I got a bit confused by this until we found this article on GitHub on the TTK about basically the same issue. And the issue is basically down to this load text context, which we're using to import the APIM APIs. And that apparently generates a variable with that name to store some information in it. And it's that that's getting complained about. There is a PR open to fix this, but it's not in the TTK yet at the time of recording this. So what we've done is we've followed the workaround here, which basically has us load that file in as a base64 file and then extract it from base64 to plain text in the variable to get around that. And that doesn't have the same problem with the variable, and that allows it to work as you would expect. So that was the first problem. The second issue was then down to some warnings. So we ran this pipeline and it failed. If you actually go look at the TTK testing, it shows you this warning that it expects the CPU value to be a type of integer, but we've got it as a string. These are actually just warnings. They're not failures, but they do fail the task. But if you actually go back to the tests, it actually passed 100% of the tests. So it's not failing the tests. It is just failing the task because of the warnings. So probably need to have a look at the TTK extension that I created to see if we can do something about that. But in the meantime, what we ended up doing was just fixing this up. It's in the ACA section here, and the CPU section, I just upped that to 1 for the purpose of this. So the problem you've got is we had a 0.5 CPU, which is perfectly valid for ACA, but because it fixes an integer field, if you just do 0.5, it complains about it and actually gives you an error here. If you put that in quotes, like I did, it does actually work, but then it fails the TTK. Bit of a cheat. We will just set it to 1. Obviously, if you want 0.5, that doesn't quite work for you, and we'll have to figure out a way to deal with that. But in the short term, we'll just change that. If we go back to our pipeline and look in here, you can see it's showing as green. It looks good. And if we go in and look at the tests, then you can see 100% passed, which is what we would expect. So that's all good. If we go back to our pull request in GitHub, we've got that here. And if we scroll down, we can now see that all our checks have passed. That's successful. Now, I can't merge this yet because it requires a reviewer, and this is one of the settings we set on that branch policy. The problem here is that I don't have anyone to review this, so I'm a bit stuck. So what I'm actually going to do is going to go over here into the branch protection rule, and I am going to turn off the requirement for reviewers. Now, I don't recommend you do that in your environment, and you should have somebody review these things, but as it's just me here doing this, I'm going to do that, and we will save that. And apparently I have to authenticate to change that. So let's just do that. Okay, and if we go back to our pull request now, we should now be able to merge it yet because it doesn't require any commits, any comments, sorry. It doesn't require any approvals. So we're ready now. We've got these changes are all in our branch. We want to merge them into the main branch. We've run all our tests. They've all successful. So we're going to go ahead and we've got the merge pull request option. You have some options here how you want to do the merge request. The default just creates a merge commit, which basically takes all the work you did and put it into main. That's perfectly fine, but all these different changes I did, is quite a lot of them, they will then end up on main as individual changes. Sometimes you don't want that. Sometimes you've done a lot of iteration on your branch, you've done lots of different commits. You don't want that full list added into your main branch. So what instead you can do is a squash and merge, which basically squashes it into a single commit, and it will put that into the main branch as one big lump. And that's what we'll do. So we'll click squash and merge, and then we will click do that. This here is then our comment about what we did with the merge. Takes basically the list of what the commit messages we used. You can obviously edit this and change it however you want. We're going to leave that as it. So we'll confirm that and I'll merge that together. And that's now in main. The PR testing branch still exists. So I'm going to click the delete branch button to remove that. And that is it. So now if we go look back in code, and we're on the main branch, and if we go have a look, for example, in the infrastructure and one of the changes we made, so let's look at the ACA one, we made that change to the CPU, and you can see there now we've got that one CPU set rather than 0.5. All those changes have been merged in. So that's it for today. What we've done, just to summarize, is we've taken our Git repo and our code we've got in there that works well and does our deployments for us, and we've added some governance around it. So the first thing, we added some branch policies and we made some changes to make sure that people can't just commit anything into the main branch. The main branch now becomes our sort of point of reference, our truth, and it's what's going to get deployed into perhaps our production environment. And we've forced people to actually not be able to commit directly to that, so that when they want to make changes, they are going to have to work on branches, make their changes on a branch, test those changes themselves, and then when they're ready to put them into the main branch, they use the PR process, the pull request process, to get that moved in. That means there's now a process around how people get their changes into the main branch. Someone's got to review those changes. And then we also added in an automated test where we looked at running the ARM TTK as part of the deployment to check that those templates that we've created are following best practice and not allowing a merge until they've been approved. Once that was all done, everything was working. We then were able to merge our change into the main branch and everything worked. That's it for this week. Next time, we will have a look at some more work around governance, particularly around testing, and look at things like how we can do integration testing and things like that. So hopefully I will see you then.